Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! This is the second video in a series about learning how to read electronic schematics, specifically related to tube audio. And if you didn't watch the first video, I suggest you go watch it. It goes over what all the symbols are that are used in schematics, and it's the building block to what we're going to do in this video, which is actually going through a few different schematics and showing you how the symbols interact and how you can figure out where the wires need to be connected inside the amp. Because again, I really don't like the idea that people might be building some of my projects blind and not understanding where things go exactly. I've had people email me and say, can you send me a really close-up shot of this tag strip so I can see which wire goes where? You know, you should be able to figure that out on your own. And if you can't, and you have to like look at a picture of how one was built to figure out where the coupling cap goes between on the two different tubes, that's a problem. And you should be able to, you know, read a tube data sheet. And that'll probably be the next video I do in this little series, is how to read a tube data sheet and get the information you need to understand how the tube works and what it needs to be happy. So anyway, this video we're going to go through my 6SQ7 amp, we're going to go through the Blue Glow KT88, we're going to go through another little 6V6 amp, and then there's a 2A3 schematic that we'll kind of touch on at the very end. And mainly not talking about how the amp actually works, it's more just kind of going through and showing you where the symbols are and where things connect to each other inside the amp with a little bit of the theory of it. So anyway, let's get to it. So let's go over a power supply and let me point out all the different symbols that are used in it. This is symbolizing the 3-prong power plug-in. There's the hot, the neutral, and the ground. The hot should always be fused right after the input into the device. It should be the first thing in the chain. Then you have the switch, goes through the primary of the transformer and back to the neutral, and then we can see the ground pin is hooked up right here with the ground symbol. So on the other side, let's start at the bottom. Here's our 6.3 volt, goes over here, and it's labeled, this little symbol here is the tube filaments, and then we have 200 ohm resistors, and then between the two of them we have a ground connection. And what this is doing is creating a virtual center tap for this winding. If you happen to be using a transformer that has a center tap on the heater winding, you could just hook that center tap to ground and not install these 200 ohm resistors. So the next is the high voltage winding, which is 355 volts on each side of the center tap, which is 0. So it's got 355, 0, 355, and the 355 volts on each side of that winding goes to the plates of the rectifier tube, and then the center tap, here you see it, they did a little jump over thing. Even though they have the dots, they still showed a little jump over thing for the wiring. Comes over here to this ground bus. Okay, so we have the 5 volts, comes over here to the heater on the rectifier tube. We're pulling the high voltage DC off pin 8. It comes over here. The first device here is this 22 UF capacitor. And as you can see, it's like a film cap. Doesn't have any plus or minus markings, and both the lines are straight. So they're specifying to use a 22 UF film cap. Here's our first inductor, labeled 5 Henry. It's got the inductor signal symbol, and you can see this one does have the little squirrely loops. Sometimes they have little humps, but sometimes they're squirrely loops, and whoever drew this liked the squirrely loop type. So then he comes here, got the second cap. This one's got a plus sign, and it's got a curved bottom, where the curved bottom always goes to negative. It's got a plus sign, so that's an electrolytic cap. We got another inductor here. We got another electrolytic cap. And then right here is the output of the power supply, and it's labeled B+. So here's the diagram for the signal part of the amplifier. We got 410 volts of B+, with a little arrow, showing that's where the power comes into the circuit. Comes up here, goes through the output transformer, comes out the other side, and this is a schematic that I drew and designed. I put the voltages in here for people building the amp to make it easier for them to make sure that they've got everything wired right. So the top of the output transformer comes over here to the plate of the output tube. This is the ultralinear tap. It comes off the transformer, goes to this 1.2K resistor to the screen. I've got pin 1, which is the suppressor grid, hooked up to the 8 pin, which is going to the cathode. And then it comes down here. We have 30 volts sitting right there. We got a 500 ohm resistor. And then we got our bypass cap that's labeled with a plus and a minus, signifying that it's an electrolytic cap. And down here it connects to this ground bus, which again shows the ground symbol here, shows that that's grounded. So we come off the grid of the tube. We come down here to the grid leak resistor, which is connected to ground. And now let's jump over to the input side. Here's where the AC or signal comes in to the amplifier, or the music as you'd say. Got a potentiometer here. It's got ground on one side, signal on the other. The wiper on the potentiometer can vary between full volume, which is over here at the input side, or no volume down here at the ground side. Comes up here. We've got a 1 mega ohm grid leak resistor, which isn't absolutely necessary, but I put them in my amplifiers so that if something happens with this potentiometer, we always have the grid reference to ground so that the tube doesn't red plate and bad things happen. Here's our grid stopper that goes to the grid of the tube, helps prevent oscillations. This tube has a couple of little diodes in here that we're just connecting straight to the cathode, and then through this LED, which has a 1.6 volt drop across it, then a 160 ohm resistor that goes to ground. Go back over here to where the B plus comes in, goes through this resistor. It's got this electrolytic cap here. We get a little bit of voltage drop, and this also helps filter the AC going to the signal tube from any pulsations and current that might be over here at the output transformer. Here's our plate load resistor. Comes up here, we got 250 volts, so this is the voltage drop across that plate load resistor from 405 to 250. Goes to the plate of the tube. And then we ground pin 1 it's a shield that helps keep the tube from being microphonic or picking up extraneous noise. Here we have the signal coming off the plate of the input tube. It goes to this 22 UF film cap. Here's another grid stopper, and it goes to the grid of the output tube. Then the last thing, we have a resistor coming off of the plate of the output tube over to the plate of the input tube. It's called a shade feedback resistor, and it helps reduce distortion and can be used to tune the sound of the amplifier. So that's showing you all the different symbols and how you go through the amp and look at how things are wired up. Oh, and one last thing is this is the output. There's your 8 ohm tap on the output, and then here's the ground tap, and then this is also hooked to the chassis ground. I always like to do this for safety in case something inside this transformer shorts out. You can't end up with high voltage on the speaker terminals. It'll blow the fuse. So having this ground in place is very important. So let's look at another example of a power supply. This one looks very similar to the last one because I used this as a starting point for my diagram that I used on my EL34 amp. So we won't go back through this again, but as you can see, it's same layout, same drawing, just the type of transformer and the chokes and stuff were changed. But here's the amplifier itself, and this does have some differences, so let's go through this. Here's the symbol for the RCA jack. You can either draw just, the input plus and minus, or you can draw it like this that physically represents the RCA input. And you can see the shell's grounded, and the input signal comes in here. I'm not going to explain why things are grounded the way they are in this video. That's going to be probably for a future video. But understand that when it shows the ground at this RCA input, that doesn't necessarily mean that you just ground this to the box or the chassis right there. This needs to be brought to a star ground point. All of these do. And I'll explain what that means, but just understand when you see this ground, it means that it needs to be hooked to the zero signal or the signal ground of the amp, but it doesn't necessarily mean you just hook that one wire right to the chassis. So anyway, here's our volume pot. Again, signal on one side, ground on the other. Here's our 1 meg safety resistor for the grid leak. This one's got a 3K grid stopper. Here's a dual triode example. They're using one ECC85 tube for both channels. And see, it's got the little half moon, then the other side's not there. That's telling you that you were using one side of a dual triode here, and the other channel is going to be using the other side. We have our LED symbol, got our cathode resistor here, and it's hooked to ground. Here's our plate load resistor. Here's electrolytic cap. It's got the plus and minus. Here's the dropping resistor. Again, this is the decoupling network that decouples the input power supply from the power tube power supply. As you can see right here, the B+, they have it coming in right here. Where mine came in drawn down here, they just drawn it up here with this little arrow. Either way is fine. Showing that it's 460 volts. Goes to one side of the output transformer. Here's your ultralinear tap. It does the little loop over, comes over here. Here's one side of a DP-DT switch. And they're just drawing one side of it for this channel, and it switches it between triode and ultralinear mode, which is switching the screen between the ultralinear tap and the plate of this tube, which switches the way that it operates. Top of the transformer comes over here to the plate. Again, here's your shade feedback resistor. The grid comes across here with another grid stopper. There's a grid leak resistor. Here's our coupling cap that goes between the plate and the grid of the two tubes. Then here's your cathode resistor. Here's your plus and minus again of a electrolytic cap, and there's your ground. As you can see again, they have the output of the amplifier grounded, and there's 8 ohms coming off the top of the transformer. Here's a slightly different looking one that was hand drawn by someone. And again, they're showing the ground for the power cord. And here's another symbol that I've seen used for like an earth ground. And that's like the safety ground as opposed to the signal ground. So when you see this a line like this, that means this thing's got to be hooked to the chassis as a safety ground. Some people draw them with just the other kind of ground symbol, which is okay too, but understand that this is a safety ground, which may not be the same point as the signal or star ground point, and really shouldn't be. So they're showing their 6.3 volt windings. They're showing each tube, and then they have the two 100 ohm resistors hooked to the ground that's creating the virtual center tap. Here's their rectifier tube, and In this case, this is an indirectly heated tube, which they have listed right here, and they're not showing the heater drawn in. And on this tube, it's just got a pin that comes off the cathodes over here for the high voltage. Here's your first cap. It's got a plus sign. The curve goes to the bottom. Here's your inductor. Here's another cap. Here's 4 other caps. Here's resistors going to the different points in the power supply. And he's got these labeled like left, right, left S, right S. And you'll see on the next diagram what those refer to. This is a really simple amplifier. Here's your B plus S, as referred to on the previous picture. There's your plate load resistor. There's a coupling cap, a film cap. See, there's no plus or minus signs. Notice that he didn't draw circles around the tubes. You don't have to, but it shows the tube elements. There's the plate, there's the grid, here's a potentiometer. I would add a resistor from here to ground, probably a 1 meg one, just to be safe, to make sure that we would never lose the ground reference to the grid of this tube. Here's your cathode resistor. There's your cathode bypass cap. Okay, after here it comes out. Here's your grid leak resistor for the power tube. There's your grid stopper. Put a 5K in there. Here's your cathode resistor, cathode bypass cap. It's got all these drawn, just grounded. This is your plate, goes to the transformer. Here's your ultralinear tap. And there's where the B plus comes in. Not the B plus S. Remember, it's a lower voltage. Here's your higher B plus. And then he's got this going to the speakers. I would again add a ground right here to the ground side of the speaker jack, just as a safety measure in case this transformer ever shorts out, that you can't end up with 200 or 300 volts on the speaker terminals. Now here's what a computer simulation drawn schematic looks like, and it does look a little different. These circles like this with a plus and minus in these diagrams is signifying power. And so there's your B plus, it's 295 volts positive, and then it's got these little open arrows, that's the ground. So again, there's the output transformer, goes to the plate. Here's a direct heated triode. See, there's no cathode drawn in. It's showing the actual heater. And then got 2.5 volts on each side. Got a potentiometer that pulls the cathode signal off the middle of the heater. There's your cathode resistor. There's your cathode cap. And see how it's got an open and then a closed drawn for the cap? The closed one is negative, or the solid one's negative, and the open box one is the positive. And that's showing an electrolytic cap. Same with here, another electrolytic cap. There's your cathode resistor. This is your coupling cap. It's drawn with 2 lines like that. It means it's a film cap or a non-polarized one. There's your other grid leak resistor. There's another grid leak resistor. Here's the input voltage, and it's showing it's a sine wave. And again, I don't do computer simulations. A lot of people do. And when they draw diagrams or they post them online, this is what they're going to look like. Again, here is your other B plus over here. They've got it the same voltage. There's the plate load resistor, and they've got this tube triode strapped, and then they've got the suppressor grid hooked up to the cathode on this input tube. And again, I would ground this speaker thing, but for a computer simulation it really doesn't matter because nobody's going to get electrocuted from a computer simulation. And here's another one that's an older drawing, and they're using this same open box and solid box for the capacitor, showing the plus and minus, and you can see all these symbols look the same. On this one, they've labeled these heaters H, which would go to this winding, and then these are labeled F, and they go to this winding. And then here they're signifying that they want to see a negative 45 volts between the grid and the cathode of this tube. And given this is a direct connected tube, see there's no coupling cap, there's going to be 150 volts on the grid of this tube. So anyway, not going to get into all of that today, but that's when they have these voltage things marked like that, they're telling you if you check with a test point on that point of the amp, you should be seeing 150 volts, and down here you should be seeing 195 volts for this amp to work correctly, because you want to see a 45 volt differential between this grid and this point, which is connected to the center point of this 2.5 volt output transformer winding. And I'm getting into a little more complicated thing that really wanted to cover today, but mainly I wanted to point out that when you see these little arrows with voltages marked, that's what it's signifying, is that's what kind of voltage you should see there when you're checking the amplifier. So we're back to the start of this, and I think this is a good point to wind up this video. It's gotten kind of long, but I really felt this was something we needed to get done on the channel, is explain how to read schematics. So let's wind it up here. Well, I hope you enjoyed this little two-part series on learning how to read electronic schematics. And like I said earlier, I think it's really important if you're going to build one of these projects that you understand how to read a schematic and what wires and what components are connected to where and how things are all interconnected. These aren't real complicated schematics, and as you've probably seen on my channel, I like simple low parts count amplifiers, and I'm probably not going to be building some really complicated ones that are, using integrated circuits and, using transistors and stuff to control the tube gates and grids and all that. That's not my style. And so you should be able to read these very simple schematics that we're using for these projects and be able to figure out how to wire up the tag strips on your own without having to email me, which I don't mind if y'all send me a message, and I'm happy to try to help out if I can, but I would rather teach y'all to do it yourself, and so I won't be holding your hand as much on some of these projects that y'all might want to be doing. And again, this was prompted by a viewer who sent me a message that I did in one of my builds. I think it was the 6SQ7 amp. I didn't video the soldering of the coupling capacitors and the feedback resistors. Two components, and they were lost. And that shouldn't be what's happening. And I'm not trying to shame the person that said, sent me this message, but I'm hoping that they can watch this video and learn how to read the schematic themselves and can go, oh, that's where they hook up. And again, I try to put every solder joint in some of these builds when I'm doing it, but sometimes I derp out and forget to turn the camera on until I'm already got all the components in, and I'm not going to tear an amp apart just to re-videotape putting them in. So that's probably what happened on that build. So anyway, I hope you're enjoying the channel. If you're enjoying this little mini series here, please like the video. When I get more likes and views on content like this, it makes me understand really what the viewers are wanting to see. And like I've learned, you guys like the more detailed build videos than the kind of rush through ones. And so I'm trying to do more of these detailed, focused builds. And then, some of these other, DIY learning videos have gotten a lot of views. And so I'm thinking maybe I need to do more of this kind of content. So let me know in the comments if you do want to see more stuff like this. I'd like to do a video on like reading tube data sheets and understanding what the tube needs to be happy, and so you can make sure when you're building an amp that you've got all the parameters right where the tube's going to have a nice long life and sound good. So if you're enjoying this content, like the video, please subscribe, and we'll see you real soon. Have a great day.